something on my mind. And in and went out. Chat settings. Something else I was going to do. I'll be right back. Hold on. Okay, I'm back. Oh, I know. I was going to copy this link to this whiteboard. I did not realize that there were outings scheduled for today when I had to swap this class from yesterday to today. So we're definitely recording. So if somebody was going to an outing. But anyway, I went to an outing earlier. I think there's 2 different times each semester that they do outings, and I went to Dolphin Island. Did y'all have an outing scheduled for today close to your house or not? Siri, you didn't. I can't even remember. I just always try to go to the first one as we have to do. There were in-person outings today, Xander. Did you go somewhere, Xander? Or you want to? It says, I went to go. Did you mean you want to? I think you meant you want to go. I'm trying to think. Oh, gotcha. We're talking about that when I had to move today's ACT till today. Instead of yesterday, I ended up having to run to the doctor for something, and I couldn't. They gave me 3 weeks, either an appointment yesterday at 2:30 or 3 weeks from now, and I'm like, I got to take this one. Anyway, I don't either, Xander. I'm always typing way too fast, and I don't ever read it until I hit send, and I'm like, what? What did I type? But anyway, I didn't think about outings because I have already been to my second semester outing like 4 weeks ago. And so I didn't think about it being outing day. But anyhow, we're going to start with problem number 11. And actually, we're going to start problem number 12. And then we're just going to work as many problems as we can for 45 minutes. And those people that didn't get to come, they can go back and watch the recording. I'll probably take all 3 recordings once we do the third part and probably upload them to YouTube just to make them easy to watch. The link's easy to watch, and then I'll probably send all 3 out. Hey, Evan. But yeah. But hey, Evan, did you get my email that I sent to you today? Hey, Alexis. I'm not sharing my screen yet. We are doing ACT help session today. when I share my screen, I can't see all y'all's names. And so I like to see you as you pop in to class. So I'll share in just a second. I was trying to get Evan to answer me. We had a one-on-one session today, and I think we got our wires crossed. Wanted to know if he got my email. Hey, Aaron. We're going to wait 2 more minutes, and then I'm not going to dilly-dally around. If I'm sharing my screen, Xander, let me try that. Right now, I am looking at the table view on my end, and there's 2 different table views, and I like the list because I can see everybody's first names and second names. But once I share my screen, all of that goes away. And I have to click back. I gotcha. That's helpful. It just automatically goes back to a blank screen. Okay, cool. That helps me. Sandra, thanks. You're a lifesaver. My life will go on because of you. Hey, Aaron.
Didn't you just say that twice?
Did I say hey, Aaron, twice?
I'm over here.
Hey, Sarah. And that's what happens. So once we get to table 8, once the 8th person comes in, then I can't see those tables because my screen share is over that. And I haven't figured out how to move my screen share around. But anyway. All right. We are on our second session of the ACT optional help session. If you've not used the whiteboard link, you can. I believe that everything should be filled out through question number 11, and we're going to start with question number 12 today. So it is 3 o'clock. Does anybody have any comments or questions before I get started? Because I'm going to go right to problem 12. And I do want to tell you that I apologize for having to change this session from yesterday till today. I just had a little issue that was really something I needed to do yesterday. Something that came up at the last moment. And I would not usually change I wouldn't change a whole group time for sure. We're not allowed to do that. But since this was an optional kind of something I set up, I thought it would be okay to change it. So thank y'all so much for showing up. Any questions, comments, or concerns before we get started? None? All right. I am going to go straight to number 12. I'm pretty sure that's where we left off. Let's look. Yep. Okay. If you were not here for the first session, that session was recorded. We talked a little bit about comparing the ACT to the SAT. We talked about raw, how you do the scores for the ACTs, and some general tips. So you definitely might want to go back and check that out. So if it's okay with y'all, we will just start with number 12. And we'll go from there. All right, number 12 says in the standard XY coordinate plane, the point 2, 1 is the midpoint of the segment CD. So this is a geometry problem. Point C has the coordinates of 6 and 8. What are the coordinates of point D? Now, I'm very visual, so I would have to sketch this problem out. You may be able to do it without sketching it out, but they want the midpoint of the segment, the line segment CD. So C would be on one side, D would be on the other. They want the midpoint. So they want this ordered pair. It tells us that C has an ordered pair of, no, we know the midpoint. It says the 0.21 is the midpoint. Be helpful if I could read the problem. Let's see. 2-1 is the midpoint. C has an ordered pair of 6-8. So we're trying to get to D. So there's a couple different ways that you could do this. I think this is how I would do it. I would look at my X values only. So 6 is getting smaller to 2, and it's 6 minus 4 that gives me 2. So I'm going to do 2 minus 4, and that's going to get me to -2. And then I'm going to look at my Y values. So 8 goes to 1 by subtracting 7. So I'll subtract 7 from 1, and that'll get me -6. Did that make sense to anybody? You may think of how to do this problem completely different. You know, you might think that 6 and -2 have to add up and average to be 2, because that's what a midpoint is. It's the average of the x's. So 6 plus -2 divided by 2 is 2. And 8 plus -6 divided by 2 is 1. So your midpoint is like the average of your x's and the average of your y's. To me, that's a little bit more complicated. So I just go 6 goes to 2 by subtracting 4. I have to subtract 4 from 2 to get me the next x. And then I do the same things with the 8. 8 minus 7 is 1. 1 minus 7 is -6. You could also set up a formula, but I think you probably can figure out what D is by just thinking about the situation. So I personally would draw it, but that I'm a very visual person. My brain works visually. Number 13, at his job, the first 40 hours, that's going to be important. And this is how most jobs are set up. I don't know if any of y'all have worked hourly jobs, but if you're full-time, 40 hours is considered full-time. Most of the time, 36 to 40 hours. And then at some jobs, you get paid more if you work more than 40 hours. So that would be called overtime. So it says at his job, the first 40 hours. Thank you, Sierra. You can do, yeah. Sometimes if I draw it out, I can just kind of work it out really without using a whole lot of math. All right. At his job, Thomas works 40 hours each week, and we call this regular time. Any additional time that he works is called overtime. Thomas gets paid $15 for each hour for regular time. And during his overtime, he gets 1.5 times as much. So I'm going to stop there and I'm going to talk about this. So if he makes $15 an hour for the first 40 hours, and then he gets 1.5, so that means you got to multiply 15 times 1.5. And I probably already did that. That's going to give me 22.5. So $22.50. So the $15 an hour is what he makes for regular time. And then the $22.50, we get that by multiplying 15 times 1.5. That's what he makes for overtime. Let me double check that on my calculator. 15 times 1.5. Yeah. Okay. It says Thomas works 46 hours in 1 week and gets $117 in deductions. That might be insurance, that might be taxes, Social Security, all those kinds of things they take out of our checks, out of his pay each week. After the deductions are taken out, how much is Thomas's pay? So we're going to split it up into 40 hours. Okay. He worked 46. So 40 were his regular hours. 6 were his overtime. So we would do 40 times 15 and 6 times the overtime pay, which is $22.50. And I've already got that multiplied out. So this comes out to be 600. That's how much he gets paid regular time, and overtime he gets paid $135. So if we add these two together, he gets paid $735 before the deductions. So then you have to take out the $117, and that's going to give us that final, you know, what he's actually going to make. So that would be D. If you're not working, this is a problem that, you know, if you are working and you do get hourly money and you do have deductions on your paycheck, it's going to make a little bit more sense. But if you haven't really worked a job, or your parents or your older siblings haven't talked to y'all about how you get paid, then this might be a little bit difficult. Questions about 13? Again, we have 60 problems to work. So my goal today is just to work as many problems as I can up until about 3:45 and see where we get. And then hopefully we can finish the other ones up on our last session next week. All right, we'll move on to number 14. At Sweet Stuff Fresh Produce, the price of a bag of grapes depends on the total number of bags purchased at one time. As shown in the table below, in 2 trips, Sweet Stuff to Sweet Stuff this week, Janelle purchased 3 bags of grapes on Monday, 4 bags of grapes on Wednesday. They eat a lot of grapes. How much money would Janelle have saved if she had instead purchased 7 bags of grapes in 1 trip on Monday? So to me, this is one of those problems where I go, who cares about grapes? And why are we doing this problem? This is one of those silly math problems. My granddaughters are getting home from school. So I think it said, how much does she save? How much does she save? So what we have to do is we have to figure out if she made 3 trips. Did she make 3 trips? She made 2 trips. In 2 trips, so we would figure out how much it cost her in 2 trips. Yeah, Jimmy Ann is 10,000 apples. Versus if she just took 1 trip. So we're comparing savings from a 2-trip grape purchase to a 1-trip grape purchase. Okay. My mind is everywhere. Let me slow down here. All right. She purchased 3 bags of grapes on Monday. So if you purchase 1 to 3 bags, they're $3 each. So she purchased 3 bags at $3 each. So she spent $9 on her first trip. And then on Monday, and she bought 4 bags of grapes on Wednesday. So if you buy 4 to 6, they're 2. So she bought $2.80, excuse me. She bought 4 bags at $2.80. I can't do that in my head. That's 11.12, and we're going to add that to the 9. 11.20, excuse me. So that would be a total of $20.20 if I did that right. If she would have gone 1 trip, so she bought 4 bags and 3 bags, so that's 7 bags total. If she would have gone just 1 trip, 7 to 9 bags is $2.60 each. So we're going to do 7 times $2.60, and that's going to be $18.20 if she made the 1 trip. So how much did she save from $20.20 to $18.20? Hey, Destiny, good afternoon to you. So you would subtract these 2. So $20.20, you probably can do that in your head, minus $8.20 would be a savings of $2. So, that's not really an algebra problem. That's really not a 9th, 10th, or 11th grade problem. That maybe a 9th. It's almost like a science problem to me because you're reading that chart. All right, I'm going to move on. I looked at these yesterday and I was just kind of thinking about time. Oh, number 15, you could do this one a couple different ways. You're trying to take 3% of 4.14 times 10 to the 4th. So I probably would use a calculator on this one. I'm going to put it in the Desmos scientific calculator just so you can kind of see how I enter it in. So you have to know that 3% is 0.03. So you got to know to move the decimal 2 places to the right. And then we're multiplying that by, and I actually worked this ahead of time. So I did 4.14. I might need to put this in parentheses. 4.14 times, and then it was 10 to the 4th. So I actually just did parentheses on this. And then it gave me my answer. So I'd probably just straight up use the calculator on number 15. Isabella, they're telling us that the online ACT is now using Desmos. This calculator that I'm using right now is not the graphing calculator. So I'm assuming y'all are going to be able to tell me all kinds of things after you take it in March, but I'm assuming they're talking about this calculator, the graphing calculator. I just have bookmarked the Desmos scientific calculator just so I have them saved and I can use them quickly when I'm in class. So I don't know for sure if they're using this scientific calculator, but what I keep reading is they are using the Desmos graphing calculator. So this problem I would just straight up use my calculator on. And remember, you can bring your own calculator. You can bring up to 2 calculators, but you can only have one on your desk at a time. And then we know there will be some type of scientific calculator and a Desmos graphing calculator on the online test. All right, number 16 is a straight up multi-step solving equations. So we would start by distributing the -3. That's going to give us -12x plus 15. Distribute the 2. That's going to give us 2 minus 10x. Then I have x's on both sides. And I was always taught to move the smaller x wherever the larger one is. So technically -12 is smaller than -10. You don't have to do it this way. You can move the 10, but this is how I was taught. So I still obey my Algebra 1 teacher from like 1981. So that gives me 2 plus 2x on the right. I'm solving for x, so I'll subtract 2. That's going to give me 13 equals 2x. I'll divide by 2, and if I've done all this right, it says x is 13/2. And I do see that answer. Isn't that a good feeling when you work out a multiple choice problem and you see the answer as one of the choices? I have worked out many problems where I have not seen the answer, and I'm like, crap. I can say crap, can I? And I'm like, oh, yes, it does feel amazing. Sometimes, you know, if you went ahead and divided 13 by 2, that's going to give you 6.5. And sometimes we freak out when we actually have the right answer. So don't do that freak out. Just stay a little bit calm. Go, oh my gosh, I got 6.5. I don't see any 6.5s. But look, most of these are fractions. Which fraction would be the same as 6.5? So some of y'all might have went ahead and did 13 divided by 2 with your calculator. So definitely don't overreact, especially if it's like a decimal, you know, and fraction. You could have a decimal or you could have a fraction. So a lot of times we don't believe in ourselves and we think, oh, I got it wrong. You know. Okay, so not too bad. Remember, the first 20 problems are the easiest, and then they get more difficult from there. 17 looks like a, did I forget 16? Put it on the screen. All right, 17 looks like another geometry problem. It's a right triangle. I noticed the little right angle symbol in here. It says in the right triangle ABC, shown below, the given lengths are in millimeters, which really doesn't matter because there's no units on the answers. It's just more information there to just trip you up. It says find the sine of angle A. So this is right triangle trig because I have a right triangle. So we talked about this first semester. And some of y'all have learned this SOHCAHTOA. I learned this as some old hen caught another hen taking oats away. And I shared with y'all that I had a student once that made up another little rhyme. Sine, cosine, tangent. You got it, Isabella. So sine, cosine, and tangent. This is just a way for you to remember. So it's asking for sine of angle A, and we know that's going to be opposite over hypotenuse. So we have to view this problem from the angle A. Opposite would be 7 over the hypotenuse is always the side opposite of the right angle would be 9. And as long as that's reduced, that should be the answer that they're looking for. You're not actually finding angle A, so it's not a harder right triangle trig problem. It's just one of those easier of the problems where you're just setting up the ratio. All right, so for 17, I got D. If they would have asked for cosine, then you would have done adjacent over hypotenuse. If they would have asked for tangent, you would have done opposite over adjacent. All right, number 18. You could do this one without a calculator. I want to show you with a calculator and without. I'm going to show you with a calculator first. So again, I'm using the Desmos scientific calculator here. You would actually put 60. You would do, I did parentheses, 27 divided by 64 to get my fraction. And then, let's see if I got an error over. Do my right parentheses, exponent, and then our exponent is negative 2/3. So on this calculator, you have to do divided by to get the 2/3. And I'm getting 1.777. So one cool feature that I noticed about the Desmos Scientific, and you can do this on any calculator, you just have to figure out how it works, is if you get a decimal and all your answers are fractions. So if we go back and look at this problem, all of these answers are fractions. So, okay, I get a decimal, I look at my answer choices, they're all fractions. Then you would tell your calculator to convert your decimal into a fraction. And on this particular calculator, you just hit that button and it turns the answer into 16/9. So that's how you would do it on this particular calculator. I'm going to show you how to do it by hand. And then if you have your own calculator, try this out. Take 27/64, raise it to the negative 2/3. See if you can get your calculator that you usually use to give you 16/9. Okay, I'm going to show you how to do it without a calculator because believe it or not, the ACT directions say that every simple problem can be worked without a calculator. So your negative on your exponent means you flip your fraction over. So the 64 goes to the top and the 27 goes to the bottom. And once I flip that fraction over, then the negative 2/3 becomes positive. The 3 in the bottom represents cube root. So we would take the cube root of that fraction, and then the 2 represents the power. So we would take the cube root of 64, and that'd be 4, because 4 times 4 times 4 is 64. The cube root of 27 would be 3, because 3 times 3 times 3 is 27. So the cube root of 64 over 27 is 4/3, and then we would square that. And that's going to give us 16/9. That's how you would do it without a calculator. Questions. You don't want to miss a problem like 18. Okay, they're going to get so much harder. So, you want to challenge yourself. You want to be able to do, those first 20. And I do work fast because y'all got to realize I've been doing this for 33 years. Hold on just a second. Sorry, my granddaughter wants to stay. Her dad's come to pick her up. Okay, Evan says, why does the bottom part of the fraction represent the square root? When we have an exponent, excellent question. When we have an exponent that is a fraction, the top is always the power, the bottom is always the root. It's the rule. We actually studied that this year in Algebra 2. It's just the rule, power over root. Y'all remember me drawing that tree and saying the roots are always in the bottom? The roots of the tree are in the bottom. So if your exponent is a fraction, the root is always on the bottom. Yeah. So some of you, if you're thinking about time, you might want to straight up use a calculator. You're going to have to make individual decisions. You're just going to have to decide, hey, is this something I can do? Do I know how to do this on my own, or I'm burning up? My heater's burning me up. Or do I need to use a calculator? All right. So some of these I'll show you how to do without a calculator and how to do with a calculator. And then you pick what works for you. All right, number 19. Lotto, or I guess it's Lotto, begins at his back door and walks 8 yards east, 6 yards north, 12 yards east, and 5 yards north to the barn door. There will be at Mackenzie, there will be a calculator built in to the online ACT, but you can also bring your own calculator. So if you have one that you love, like I love this calculator, like I love it because I know how it works, then you need to bring the one that you love. Do you know what I mean? You don't want to be like trying to figure out how to use a calculator on this online ACT. So if you have one that you use all the time, you know, don't go to your next door neighbor and just borrow a random calculator you've never looked at. Okay. But if you have a calculator that you use all the time, you can bring that. You can use it on the math section. Okay, Lotto's doing a lot of walking. It says about how many yards less would he walk if he could walk directly to the back door to the barn. Okay. 19 is one of those problems is I cannot figure this out without drawing a picture. So this is what I would do. So you also have to kind of know directions too. I bet some of y'all don't know your directions. How many of y'all GPS everything if you're driving? So he goes 8 yards east. This is east. And then he goes 6 yards north. Up is north. And then he goes 12 yards east. And then he goes 5 yards north. Oh, Mackenzie, I always say that Google Maps has really enhanced my marriage because we don't have to fight over directions. And I don't have to tell him where to turn. The GPS tells him where to turn, and he doesn't get mad at the GPS. But anyway, he's walking 8 yards east, 6 yards north, 12 yards east, 5 yards north, okay, to get from this spot to this spot. So if we add that up, so it's 8 and then 6 and then 12 and then 5. So if we add up 26, I think that's 31. I don't even know. Yeah. So he's walking 31 yards, but they're saying, hey, there's a shorter way. It says about how many yards less would he walk if he could walk directly from his back door. This is his back door of his house. I'm assuming it probably said that to the barn door. So if he could walk directly there. So what you do is you kind of try to create like a right triangle here. So I'm just going to redraw it right here. Oh, that looks awful. Who drew that? So if I redraw it like this, whoo, so this is 8, this is 12, so that would be 20. Are y'all with me? And then this is 6 and 5, so this would be 11. So the 8 and the 12 make 20, and then this is 5 and this is 6, and this makes 11. So that gives me this big right triangle. And then guess what I would do to find the direct distance from his back door to the barn? What formula have y'all used with a right triangle before? Starts with the letter P. Pythagorean theorem. So the 11 and the 20 would be your A and your B, A or B, and then the X would be your C. So you're going to do 11 squared plus 20 squared equals X squared. I'm going to use my calculator that I love here. 11 squared plus 20 squared. That's going to be 521. And we're not trying to find X squared. We're trying to find X. So we have to take the square root of both sides. And that gives me 22.8. So if he goes directly, it's about 22.8. I'm going to assume, since all these are whole numbers, that I'm probably going to round this up to 23. So 31, the shortcut would be 23. So he went 8 yards more than he had to. 8. Now, there were several steps in that one. And still, again, that's part of those first 20. So we know they're going to get harder. I can't think of an alternate way to do number 19. I'm not saying there's not an alternate way. All right, I'm going to move on to number 20. If y'all have something that you have a question about, put it in the chat. For a given set of data, the standard score Z, we're going to study this formula in this semester. So if you're thinking I've never in the world seen this formula before, you probably haven't. And we will study it this second semester in Algebra 2. It says Z is the standard score Z corresponds to the raw score X, and it's given by this formula. So they give you this formula. I'm going to rewrite it. Z is equal to X minus, this is a Greek symbol. I think it's mu, and this is sigma. Y'all definitely have heard the word sigma before. So it says where mu is the mean and the set of this symbol, which is sigma, is the standard deviation. If for a test score, mu is 78, so I'm just going to plug that into that symbol. Sigma is 6. Which of the following is the raw score? So we don't know the X. That's going to be unknown because it says the Z score is 2. So basically, once you read through this and you realize what they're asking you for, they're giving you a formula. And they're giving you this value, and this value. So you plug them in, and then your job is to solve for X. So because X and minus 78 are both being divided by 6, we would have to multiply by 6 first. And that's going to give me 12 is equal to X minus 78. And then we're solving for X, so we would add 78 to both sides. And X would come out to be 90 because I can't add. Y'all see that 80 is a wrong answer? They also have really good wrong answers on the ACT. 12 plus 78 is 90. Now, there is another way you could do 90, you could take each answer and you could do 90 minus 78 divided by 6 to see if that equals 2. Or you could go to the next one, 84 minus 78 divided by 6 to see that equals 2. You could do it that way also. So once you get over the fact that this might look like a formula that you've never seen, they're giving you enough information there to plug everything in except what you don't know. All right, moving on to 21. If I need to slow down, please tell me. And I am recording. You could go back and watch this, stop it and watch it. All right, 21 looks like a geometry problem. To me, it's got a circle, it's got triangles. It says in the figure below, A, B, C, and D lie on the circle of center 0. So a lot of times they name a circle. I don't know if you remember this, but they name circles by the center. So this would be circle O. And one of the things that they're not going to tell you is this segment AO and BO and CO and DO are all what? What would you call all 4 of those segments in reference to the circle? AO, BO, CO, and DO. They are congruent. Isabel, you're right. And does anybody know why they're congruent? We could mark them all with 1 dash, making them all congruent. They are a certain part of the circle. That's how we know they're congruent. All 4 of those segments. And it's weird how visually they don't look congruent. But remember, your diagrams aren't drawn to scale. But they are all congruent because they're all something that starts with a R. Each one is a radius. And y'all know that in a circle, the radius or the radii, if we're doing plural, they all have to be congruent. Okay? So they're not going to say, hey, those segments are congruent. You're going to know they're congruent because they're all radii. It says, which of the following does not have a problem with this? Because I always want to pick what's true. They're asking us what's not true, what does not appear in the figure. It says an acute triangle, which is a triangle that has 3 acute. So quick reminder, acute is less than what? Acute angle is less than 90. Equilateral, means all angles, equilateral means all sides are congruent. Isosceles, y'all remember what isosceles means? How many sides are equal in an isosceles triangle? Y'all remember that? 2 congruent sides in isosceles, and scalene. Oh, right triangle. Everybody knows a right triangle's got a right angle, right? How about scalene? I used to teach this when I used to teach geometry years ago. And I'd say, scalene triangle. That means you don't have any congruent sides. No congruent sides. I guess we could say no congruent sides. Do you want to take a guess on this one? Which one do we not have in the figure? Acute triangle would be all angles are less than 90. Equilateral triangle would be all sides are equal. Isosceles, at least 2 sides, which could be 2 to 3. And then scalene, no sides are equal. You want to take a guess? Isabella's thinking it's scalene. It is scalene. And if we kind of got a little bit deeper into this, if this angle is 60, let's go to this angle. If this angle is 90 and these 2 sides are equal, then both of these are 45. But really, this is your right triangle. So this marks this out, right? This triangle, if this is 60 and these 2 sides are equal, that means these 2 angles are equal. And if you do, all 3 angles of a circle, of a triangle, add up to be 180. And if you take out that 60, that gives you 120. And if these 2 are equal, then you divide 120 by 2. And that means these 2 are going to be 60. These 2 angles are going to be 60. So what do we know about a triangle? Let me erase this. What do we know about a triangle that has a 60, and a 60-degree angle inside? What do we know about the sides? If we have a 60, 60, and 60, if all the angles are congruent, then what do we know about the sides? They're all equal too. So that makes this triangle on the left, it makes it acute because 60, 60, and 60 are all less than 90, but it also makes all 3 sides equal, so that makes it equilateral. 60 and 60 and 60 makes it acute. And then I always thought this was tricky, but isosceles means 2 or more congruent sides. So that means that equilateral triangle is always isosceles. So we would mark that one off because of this triangle. I'm not the greatest geometry teacher in the world. That was my harder math subject when I was in high school. Okay, number 22. Let me check my time. 3:35. What is the slope of a line in standard form, xy coordinate plane, that is parallel to x plus 5y equals 9? Definitely algebra 1 or geometry. So if we're going to find slope, what variable do we need to solve this equation for? If we're going to find slope, let's start with that, because this would be something that you would have to know. If you want to find slope, would you solve for y or would you solve for x? You could put this equation in Desmos Grapher and then count rise over run, but I think that's going to take too much time. Anybody know this? If we're finding slope, then we want to put the equation in this form. Y equals mx plus b, because m means slope. Yep. Mx, that means we got to solve for y. So we would have to subtract x. That's going to give us 5y is equal to negative x plus 9. And then we divide everything by 5. And we really only care. I don't know why I think about Dracula here. Dracula only cares about blood. This problem is all about slope. So there's an understood 1 there. So that means there's a negative 1/5 in front of my x. So this equation has a negative 1/5 slope. And it says, what's the slope of a line that's parallel? So remember, parallel lines always have the same slope. So if you're going down 1 and over 5 to have, that kind of slope, down 1 and over 5, a line that's going to be parallel to that has to have the same slope, down 1 and over 5. So it's going to be G. If it would have said perpendicular, so we might want to write this down as far as reference. So parallel slopes are the same, and perpendicular slopes are opposite reciprocals. So for example, real quickly, if it would have said perpendicular here and we had -1/5 for the slope, then the perpendicular slope would be opposite, change the sign. So it'd be positive, and then we would flip this over. And it would be 5 or 5/1. Parallel slopes are the same. Perpendicular slopes are opposite reciprocals. All right, they're going to start getting harder from here. Again, we know the first 20 are the easiest. We know there's 60 total problems. We know we have 60 minutes. So you want to try to pace yourself. Skip the problems that you don't know how to do. Don't try to work on a problem for 5 solid minutes if you don't have a clue. I always say, 15, 20 seconds, you're going to know pretty well whether you can do it or not. If you can't do it, skip it. And then come back at the end when you have some time left at the end. And then we want to answer all of them. So you'll just pick an answer. And, when you have about a minute left, you want to go ahead and make sure that you answer every single problem. At least put something in there because you might get something by guessing. All right, 23. Given that y is equal to x over x minus 1 and x is greater than 1, so x has to be some number greater than 1, which of the following is possible value for y? So I looked at this problem yesterday, and since we've been using Desmos a lot, I thought you could use Desmos for this one. So I'm going to go to the grapher, and I'm going to type in this equation. I just kind of thought for the first time, I've never really used Desmos for a problem like this, but I don't know. I just had a thought. So it says if x is greater than 1, okay? So if x has to be greater than 1, which of the following must be true about the y value? So let's look at this graph, not that graph, this one. So here's where x is 1. So if I look at this graph and all the points where x is greater than 1, what do y'all notice about the y values? So we're not looking at this piece at all because this is where x is less than 1. So we're looking at all the y values on this piece. So I do have a horizontal asymptote. It's lying in between these two branches. So let's go back and look at our answers. It says, which of the following is a possible value for y? It says y could be -1.9, -0.9, 0, 0.9, or 1.9. What is a possible value for y? Do y'all see y is never going to be negative because all these points are above the x-axis? That's the first thing. It's going to be positive. So I can eliminate these two. How about 0? Is the graph ever going to get to 0? Nope. It's never going to get to 0. 0 is way down here. And then if you look at the y values, they're getting closer and closer to 1. But they're never getting to 1. So that means it can't be 0, it can't be 0.9, but this is the only possible one. Now, if you didn't want to use the grapher, you could, you could make a t-chart and put in some x's that are bigger than 1. So you could put in 2, sorry. So that would be 2 over, I'm going to do my work down here, 2 over 2 minus 1. That'd be 2 over 1. That'd be 2. 2. You could put in 3. So I'm just putting the 3 in the place of the x. 3 over 3 minus 1. That's going to be 3 over 2. That's going to be 1.5. 4. 4 over 4 minus 1 is going to be 4 over 3, which is 1.3. You could see a pattern here. And you could see where you're never going to get negatives. You're never going to get 0. And then, you know, but I thought the Desmos graph was revealing. I thought I don't know. I just thought about it for the first time. So I kind of like Desmos on this one, if you had that choice. If you're not able, let's say on this problem, you're not, maybe, let's say they restrict you. Since this is an online ACT, what if only certain problems allow you to use the graphing calculator? That's also a possibility. I don't know the answer to that. We just know there's a graphing calculator on the ACT. We don't know that every single problem has it. So something to think about. All right, 24. Let's do maybe 2 more. It says 24, the set of all positive integers that are divisible by 15 and 35 is infinite. The set of all positive integers that are divisible by, so that means that 15 can divide into and 35 can divide into, are infinite. What is the least, which means the smallest, positive integer? Okay, so I don't know how you would do this. This is how I would do it. I would count by 15. So I would say 15, 30, 45, 55, 70, 85. I would start counting by 15s, okay? And then I would count by 35s. 35, 70, 105. Okay, so I got bigger quicker because I'll start with 35. 85 plus 15. Sorry, I can't do that in my head. 85 plus 15 is 100. I messed up somewhere. 15, 30, 45. Sorry, I messed up right here. You could also say, will 15 go into 5 and will 35 go into 5? No. Maybe you want to do it this way. Will 15 go into 50 and 35 go into 50? No. Will 15 divide into 105? I don't know. Take your calculator and do 15 divided by 105 and do 105 divided by 35. The answer is 105. Because I added wrong here, I didn't get to 105. Here's 105 here. If I would have added correctly, 45 plus 15 gives me 60. 60 plus 15 gives me 75. I think that's where I messed up. 75 plus 15 gives me 90. And then 90 plus 15 gives me 105. You could find it that way. Or you could just say, what's the smallest number that 15 and 35 divide into? All right, let's do one more. And then we'll stop and see if anybody wants me to go back and explain one of the ones that we did today. All right, 25 says, in the triangle ABC shown below, the measure of angle A is 58. It's already labeled. It says that segment AB and AC are congruent. So I'm going to mark those with my congruent symbols. And it says, what is the measure of angle C? So we're looking for angle C. What's the sum of all the angles in every single triangle in the whole wide world? What's the sum of the angles of any type of triangle in the whole wide world? What do all 3 angles always add up to be? 180. Good. So if I take 180 and I subtract out the 58, that's going to give me 122. And we have a theorem in geometry that says if 2 sides are congruent, then the angles opposite those sides are congruent. So these 2 angles are the same measure and they add up to be 122. So I can divide 122 by 2, and that's going to give me 61. So each one of these would be 61, and they're just asking me for angle C. So this would be an isosceles triangle where this would be considered the vertex angle, and these would be the congruent base angles. All right, I'm going to make a note that we're going to start with 26. Anybody want me to go back to any of those problems? We started with number 12. If both sides are equal, then the angles opposite of those sides are equal. So that triangle is like this. This side is congruent to this side. Then these 2 angles down here would always be equal. The angles opposite of the congruent sides. All right. We'll meet again Thursday of next week. And we've got 26 through 60. And my granddaughter did an experiment. Let me show y'all. Don't open it yet. Come here.
Don't open it. It might not work.
So she loves Nutella. She eats Nutella. You want to tell them hi, Randy?
No.
She eats Nutella on her toast every morning before she walks to school from my house. And so where did you see this experiment?
YouTube?
She saw it on YouTube where when you got to the end of your Nutella jar, instead of throwing it away, you mix milk on the inside. We did it this morning. She just got it, and then you freeze
I don't
it.
think it's going to work.
And it's supposed to be Nutella ice cream. So she's
It
just,
works. Whoa. I'll go get a spoon.
here you go.
I don't feel scary. It smells good.
It does smell good. All right, Evan says, and you divide the length of the sides by the number of congruent sides to get the angle. You could think of it that way, but you're always going to divide by 2 because there's always going to be 2 congruent angles. Isabella, good point. So the overdues manually have to be removed. So
It works, just it's too hard.
So I manually remove those overdues for bonuses on Mondays because I feel like I at least need, for students that might be a day or 2 behind, that they need to see that those were due and see that they're a bonus. And then on Monday, I remove the due date and the overdues go away on the bonuses. It's a manual thing that our system doesn't do on its own. So Monday, I'll remove the due dates for anything that was bonus this week, and then those overdues will go away. I know that's, yeah. So I have to put a due date on it for it to show up. Or anybody need me to go back to a slide? Thank y'all so much for giving up your Friday afternoon to come to ACT Help. Again, I am recording. I know I was working pretty fast, so you could definitely go back and watch that recording. All right. I'll hang around for about 1 more minute, and y'all are free to go. Have a wonderful weekend and a good day. You have a good day also, Destiny. Bye, guys. You're welcome, Isabella. Bye. Thank y'all for coming. Bye, Lily.
Not sure if you can see this.
I can hear you, Xander. Are you sharing something? Okay. I have to stop sharing for you to share. You promise that it's class friendly? Bye, Evan. I think the last time you shared a picture of Skibbity Toilet, and it's forever in my mind. I'm waiting, Xander. Oh, share your drawing. You can share now. I was sharing, so I had to stop sharing so you could share. We can't share at the same time. Share it. Share your drawing. I want to see it. Share, 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 share. Hey, Leo. I'm just seeing some of y'all. My shared screen was over some of y'all's names. I hate that. Hello. Sanders wanting to share a drawing. I can't see anything. Oh, wait. Have you got, hold on. So you're just, I'm on the wrong screen. Xander, your camera, no. Where are you at? Xander. Xander, your camera, I just see a big blue dot. There we go. I thought you were sharing a screen on your computer. Cool. Tell me the story. Yeah. What is your drawing? Hi. Oh, your imagination. What a wonderful thing. I wish I had a better imagination. I can see that you have a big imagination. Thank you for sharing that, Xander. All right. Bye, guys. Bye, Ariana. Bye, Leo. Bye, Venetia. Bye. Bye, Xander. Y'all have a good day. Bye.